My name is Devon with Math Mentors, and today we're looking at more special right triangles. So today we're going to be looking at what's called the 45, 45, 90 isosceles right triangle. It's going to be really funny if I misspelled isosceles, but it's fine. So the idea of this triangle is we're going to draw it like this because it makes it a little easier. We have a triangle that looks something like this. And the idea is this is a right angle. And we have these two angles here that are both 45 degrees. That is what makes this isosceles, because we have the base, and the base has the two same angles that go this way, right? So the secret and like the trick with this, the shortcut, is that you can assume that both of these sides, first of all, both of these sides are equal. So they're both equal to x, variable x, which means the hypotenuse here, the shortcut is that the hypotenuse, if the side is x, is that this is x times the square root of 2, which can come very in handy when you're solving for the length of different sides of triangles and you notice you have a triangle that meets the criteria of being a 45, 45, 90 triangle. This won't work if it's not a 45, 45, 90 triangle. If, say, it's a 30, 60, 90 triangle, you have to use the 36, 90 triangle shortcut. So to give a little bit of an example with this, let's assume we have, hold up, let's make a nice little triangle. Boop, boop, duh. Really trying to make one that looks kind of pretty. You know what, that'll do. So let's assume, again, we have our 45, 45, 90. Let's assume we have the side here of 4. And since this is equal to this side, this is also 4. And since this 4 is this x, I did like kind of flip the triangle, but you have to remember that orientation doesn't matter as long as the inside angles are correct, right? Excuse me. So 4x, where the x is, correlates to this. So if 4 is x, then 4, this hypotenuse would be 4 times the square root of 2. And again, this can come in handy if you don't want to have to use, a squared plus b squared equals c squared. Because, I mean, it's not hard to do, but it's not something you want to do if you don't have to. And this is a shortcut to that. So it comes in handy when you notice you may have a 45, 45, 90 triangle. And you can use a shortcut, right? So I hope this helps you gain a little bit more of an understanding on the 45, 45, 90 isosceles right triangle. And I hope you have a good day.